Alrighty, folks, I got a little HVAC lesson for you tonight. Tonight's HVAC lesson focuses on how a window air conditioner works. Well, actually, on how any air conditioner works. So, we're going to focus on my 1965 Fetters weather wheel for this lesson here. And I'm also going to explain to you how a refrigeration system works, because that's what the air conditioner uses in order to cool the air. So anyway, let's get into it. So the heart of any refrigeration system is the compressor. So what the compressor does is it takes a refrigerant and compresses it into a hot, high pressure gas. So the compressor will take in cold, low pressure vapor and turn it into a hot, high pressure gas. So anyway, let me show you that here. So in this case here, we got my Fetters weather wheel with a Tecumseh AJM 15-94 reciprocating compressor. So a reciprocating compressor consists of a piston driven by an electric motor in order to compress the refrigerant. So that's where it all starts. So the refrigerant, which in this case is R22, the refrigerant enters the compressor via the suction line. And what happens is the refrigerant is coming in as a cold, low-pressure vapor. And so what happens is the compressor is going to compress it and turn it into a hot, high-pressure gas before it leaves the compressor. So refrigerant would come in like this, and then it gets compressed. And then there you go. You have a hot, high-pressure gas. So this tube right here, this is the discharge line. So the hot, high-pressure gas will travel along that line to the condenser coil, which the condenser coil is this big guy right here. So the refrigerant will leave the compressor like this, comes along, and enters the condenser. So what's going to happen in the condenser is the refrigerant is going to start to change its phase. So instead of it becoming a hot, high-pressure gas, it will transform into a cold, high-pressure liquid. So as the refrigerant moves through the condenser, it will change its phase and become a cold, high-pressure liquid, or a cool, high-pressure liquid. So what happens is once the refrigerant leaves the condenser, which it leaves the coil right here, so I don't know how well you guys can see that, but it leaves the coil right here. And then that's our pinch-off point where they filled the unit with Freon R22. And then the refrigerant, because it's a cool, high-pressure liquid, it then enters what's called the capillary tube, which is this little guy right here. So the refrigerant will go through the tube and turn into a cold, low-pressure liquid. So then what's going to happen is, so then what happens... So the line that runs between the condenser and evaporator, that's called the liquid line, which is this line right here. So when the refrigerant enters the evaporator, it's going to start to change its phase again into a cold, low-pressure liquid. So it comes up along... So my Fetters is pretty unique for having a dual evaporator. So the refrigerant... So basically, like I said, what the evaporator does is it allows the refrigerant to change its phase so it evaporates. So here in the evaporator coil of an air conditioner, which is what we're focused on here. So basically we're going to start back over here at the condenser coil. So I forgot to tell you guys, in an air conditioner, which is very unique. So let's come back to the evaporator here so you know how heat transfer is done. The air conditioner will suck air in via the squirrel cage fan here, and it will send it through both evaporators, which then the refrigerant, the R22, will be a cold, low-pressure liquid at first. And then as soon as it enters the evaporator, that's when it's going to transform into a cold, low-pressure liquid, and then it's a heat-absorbing gas. So what will happen is as the refrigerant flows through the evaporator coil, the refrigerant will absorb the heat, and once it leaves the evaporator, it comes back along the suction line here to get to the compressor. So then, as I said before, the compressor will, the heat is transferred to the compressor, which then sends the heat out along the discharge line, as I said before. And then in the condenser coils here, that's the part of the air conditioner that you find outdoors. On a central unit, that's your outdoor unit. On a window unit, it's your outdoor half. So anyway, looking closely here, so the condenser coil, and so heat transfer is maximized via the coils and the fan. So the condenser fan, or outdoor fan, depending on what type of air conditioner you have, is spun via an electric motor. So the electric motor will spin the fan to blow air over the condenser coils to keep them cool. And it also keeps it from overloading the compressor. Because if you let the system run too long without the fan, then it's obviously going to overload the compressor, and then it will cause problems eventually, or damage the compressor to make matters worse. But anyway, guys, fans' jobs are to transfer heat. So as I said before, the room temperature air gets thrown into the evaporator, or evaporators if you have a Fetter's weather wheel. So, as I said before, the air that gets thrown into the evaporator or evaporators, the air will suddenly get chilled via the coils, and then what will happen is the low pressure vapor absorbs the heat. So then when you return the refrigerant back to the compressor, it starts the cycle again, and then the heat is gotten rid of via compression, and then the air conditioner dispels the heat outdoors. So therefore, that's how an air conditioner works. So, and another thing too, guys, if you have warm, moist air, the evaporator will start to make what's called condensation, or condensate for short. And what that does is, now window air conditioners, this is especially important. So anyway, my Fetter's weather wheel, which is what we're looking at right now, I noticed it had a little bit of coil rot due to all the condensation it made over the past 20 years it was in service. But anyway, so basically what you want to look for is, on the evaporator, you want to look for water drop. You'll know an air conditioner is working properly. So the one thing you got to watch out for too, by the way, before we get into how can you tell if it's working properly, is frost. So that's another reason why you shouldn't run an air conditioner for too long without the fan. Not only will the head pressure build up and overload the compressor, but it can also cause the evaporator to frost over, or even worse, freeze up. And it could cause some major issues with the unit. Now, rotary compressors are especially prone to this. If the coil freezes up due to like a dirty condenser or something like that, the evaporator will freeze up and it could damage the compressor, because rotary compressors are not designed to handle liquid refrigerant. Now, reciprocating compressors can handle a little bit of liquid refrigerant. So this particular compressor here, my Fetter's Tecumseh AJM 1594, has an anti-slug feature, which keeps liquid refrigerant moving at all times. So anyway, guys, now rotary compressors in air conditioners have what's called an accumulator. So just before the refrigerant enters the compressor, the accumulator will collect liquid refrigerant and evaporate it before it enters the compressor. Now, reciprocating compressors, on the other hand, they're designed to handle a little bit of liquid refrigerant. So that's why some systems in particular contain an anti-slug feature in the compressor. Now, I can't show you guys a scroll compressor because obviously I don't have central air. But in you can check out some of my other videos to see units with scroll compressors. But anyway, guys. So basically, the heart of refrigeration. So I'm gonna do a brief go through again for those of you who are kind of still a little unfamiliar with all the information. So the compressor, therefore, that's the heart of the system. So like I said, the refrigerant leaves the discharge line and heads for the condenser, which will then, therefore, it will liquefy and turn into a cold, high-pressure liquid. So like I said before, the compressor makes the refrigerant a hot, high-pressure gas. So as the system runs, the refrigerant goes through the condenser and liquefies to become a cool, high-pressure liquid. So then, and then the cool high pressure liquid will run on a capillary tube, and it will therefore turn into a cold low pressure liquid. So then the liquid will once again, it'll enter the evaporator, and then that's what's going to allow the air conditioner to chill the airs, the evaporator coil. Now, the one unique thing about some air conditioners, like the Fetter's Weather Wheel in particular, is you can make one evaporator out of 2 coils if you use the right connections. So in that case, that's what we got right here. We got the 2 longer connections there to make 2 evaporator coils, 1. So anyway, that's pretty much how, and then as I said, the refrigerant comes along the suction line back to the compressor, and the cycle starts again. So now we're going to get into some safety precautions here. Why you should never run a refrigeration system without the fans running. So in air conditioners especially, like if you have one with like a weather wheel with a reciprocating compressor, you should definitely not overload the unit, because it could damage the compressor, and it also could start a fire, if it arcs bad enough. But anyway, that's why we have like circuit breakers and fuses and ground fault circuit protection. All the safety stuff that keeps us safe when incidents like those happen. So anyway, some safety precautions. Always unplug the unit or turn off the power at the service panel to that circuit that the air conditioner is plugged into, in case if you can't unplug it, or sometimes it's better to just make sure your circuit panel circuits are labeled, because there's nothing worse than going to work on an air conditioner that's still plugged in. But I always just unplug the unit. So big safety precautions: unplug the air conditioner before you start work on it. Or if you're working on a central unit, shut off power to it at the service panel. Or if you have an outdoor disconnect. Anyway, another thing too, guys, is if you're acquiring like an older air conditioner, a little tip here. If you don't always think, the fan motor still works, it might be that way for a while, and then what happened to my Fetters, the fan motor will crap out eventually. So anyway, that's why you should always test the motor windings first before you even run it for the first time after getting it. So anyway, and you should also check the compressor too. And another big safety thing, guys, check that out. You got a capacitor right there. So never ever touch the capacitor terminals with your bare hands, because those capacitors, which this one's charged to 370 volts and 25 microfarads, it's enough to kill a person. So please do not touch those capacitor terminals. And you should always discharge a capacitor first, even if you think it has no power, because you never know if they still have a charge or not. So, word to the wise, always discharge capacitors before testing or working on them, or even handling them. And always unplug an air conditioner before you start work on it. And another thing too, guys, if you're working on the compressor, if you have this junction box door removed, make sure to put it back on before you put power to the compressor. Because I've never had it happen before, but I've heard of incidents where people accidentally left the junction box door off the compressor, and then they accidentally bumped the terminals and received a pretty good zap. So be sure to put the terminal cover door back, the junction box door back on before you start it up again. And anyway, also make sure the fan is clear of obstructions. Like if you notice the fan's not spinning, shut it off right away. Don't burn up the motor. Just shut it off, clear the obstruction, and turn it on again. But really another thing too, guys, is to make sure the fan motor is lubricated, so that way it doesn't seize up and burn up the windings. Now my Fetter's fan motor spins very freely. You guys can see here, it spins nice and free. There's no noise from the bearings or anything, which means the bearings are good. So anyway, guys, and another thing too, make sure the coils are clean, because if you forget to clean the filter, or if you don't even have a filter for it, you know, it could cause the coils to freeze up. So be sure that you be sure that you check the coils. And also I recommend too, unless you have a real large unit. Now with large units, guys, all you have to do is just take the screws out and just pull it out of the chassis a little bit. So then pretty much everything is accessible, without having to take the unit out completely. With small units, you can just simply pull them out of the window or take them out of the window and service them that way. But make sure you take the casing off though before you and also make sure you unplug it too. Anyway, guys, I think that's about it. Also, never ever touch switch terminals if you don't know if they work. That's another big one, guys. Be sure to not touch the switch terminals at all, because there's nothing worse than getting zapped by switch terminals. Because it's like they say, guys, it's not the volts that kill you, it's the amps. So remember that saying, and stay safe out there, guys. If you have any questions, feel free to ask, and we'll see you in another video.